So when we try to solve these proposal acceptance rejection kind of game, we always solve from the end. So basically the last round, and then we go back using backward induction. So one assumption or one trick to solve this is always we want to propose the thing such that the next guy will basically accept. So what it means is in equilibrium or in the solution, the first proposal will actually be accepted. So basically, in all subgames, the proposal will be accepted at the beginning. So that's always the trick that we use when we solve these proposal games. So for this particular question, there needs to be one change. So if a pirate is indifferent, he or she will reject with probability half. If he or she will reject for sure, then this game cannot be solved. But in any case, at the beginning there are five pirates, and as I said, we saw from the end, so the last round. So in the last round, only five survived. So if the game reached last round, then all four of the previous pirates will be killed, and only five survives, and five will get 100 gold coins. So then we go back to the previous round when four is proposing. So four will propose so that five will accept. So as I said, that will be a trick to solve these. So we're proposing a way that five will accept. So five can only accept 100 gold coins. So the only way to propose is give myself 0 and give five 100. So, and in that case, given this half assumption, four will survive with probability a half. And then we go back to the previous round in which 3, 4, and 5 are still alive. So 3 is proposing. So again, 3 wants to propose such that the majority will accept. And majority means among 3 people means at least 2 people accepting is okay. So if I want 5 to accept, then I need to give 5 100. So I don't want to do that. If I want 4 to accept, that's a bit easier. I can just offer 4 0, and I can keep all 100 coins, and I can give 0 to 5. So this is 3, 4, and 5. Then I will vote yes, 4 will vote yes, and 5 will vote no, obviously. But majority voted yes, so I will not be killed, so that's good. 3 will survive, and the proposal will basically be accepted. And then we move to the previous period when 2 was still alive, and then 2 will need how many votes? There are 4 people, so 2 needs 3 votes because the assumption of strict majority. So strict majority means if there are four people, I need strictly larger than 2 votes. So we need 3 votes. So it's very difficult to get a vote from players 3 because I need to give him at least 100 coins, and I have nothing left. So I'll probably give 4 and 5 1, and myself the remaining. So I'll give myself 98, give 3 0, and give 4 1, and give 5 1. So note that if I give them 0, they will reject with probably half. So I don't want to risk my life. So I want to for sure, I want to survive for sure. So that's why I will give them 1. So here, I will vote yes to myself, obviously. So 4 will vote for me because if 4 choose to reject, then 4 will go to the next round. And in the next round, 4 can only get 0. So 4 will prefer 1 to 0. And of course, 5 prefers 1 to 0 as well. So 5 will vote for me as well. So only 3. If I wait, I'll get 100. If I don't wait, I'll get 0. So of course, I won't vote for you. But then in this case, 3 people voted yes, so 2 will survive. So you can go back to the beginning of the game, then you know one will propose in a way such that at least three people will accept. Because there are five people in total, I need three as the majority vote. So I will give which three should I try to kind of bribe to vote for me. So zero, obviously, and one of the ones will be good. So in particular, let's say the last one. So I'll give myself 97, and I'll give two zero. I'll give three one because one is preferred to zero, and I'll give four zero as well. I don't care about his vote. Two, and I'll give five probably two because I give one, then five is indifferent, so I risk getting killed. So now I will vote for myself. Three would prefer getting one than zero in the next round, and five would prefer getting two than one in the next round. So these two people obviously will not vote for me, but I got majority vote already, so I will survive. So that would be why the answer is D.